All right, today we are going to take a look at simplest radical form when fractions are involved, meaning really also when division is involved. So the only rule that we add to simplest radical form, we're still trying to get the lowest number possible under the square root, but there can be no roots in your denominators. That is the only rule we add. Okay, is that there can be no rules in your denominator. That's it. So what we have to do is we have to figure out how can we kind of get rid of roots in denominators once they kind of are there already. So as this first example shows, both of those roots individually are totally simplified. Everything there is fine. However, we have a root 7 in the denominator. What we know that we're allowed to do with fractions, from like addition and subtraction of fractions, is that we're allowed to multiply the numerator and denominator by the same thing, because that doesn't change the value of the fraction. So what we're going to do is we're going to multiply the denominator and the numerator by the square root of 7. What that's going to do is this. On top, we're going to get the square root of 35. On the bottom, though, when you multiply the square root of 7 times the square root of 7, you get the square root of 49. And 49 is a perfect square, so we're just going to turn that right into 7. Now, you don't even necessarily, I'm hoping, need to write this step in the middle, and you can just skip to there. When you see square root of 7 times square root of 7, we should realize, oh, we're creating the perfect square, 49, and we should be able to go right to 7. That's going to work for anything. So, like for example, if you were to multiply the square root of 11 times the square root of 11, you would get 11. You don't really need to do the math. You're creating 11 squared, and then you're square rooting it. Okay, so that's kind of what we're going to do. Now, when you get to an example like B, we have two separate issues that we need to deal with, and you can deal with them in whatever order you wish. So we have 8 root 24. The square root of 24 is not simplified as much as it can be. We could take a perfect square out of there. And we have a root in our denominator. I'm going to kind of show you both paths this time, and then in the future, you can kind of pick which method you want to use. So I'm going to multiply by root 24. That's my first method. Now this one ends up being a little bit different in that our denominator is 24, but our numerator, we cannot multiply the 8 and the 24 because 8 is outside of the root, 24 is inside of the root, so we can't do that. Now we have a couple other problems to deal with in that the square root of 24 is not simplified and the fraction itself is not simplified. Now here, I am for sure going to simplify the root first, because I don't want to end up having to simplify my fraction multiple times. Okay, the square root of 4 is 2, and 8 times 2 is 16. So I get 16 root 6 over 24. Now I can simplify the 16 and the 24 because neither of those are in my root. They both divide by 8, so I get 2 root 6 over 3. I'm going to show you the other path that you could have taken there as well. So what you could have done is you could have simplified the square root of 24 right away by changing it to 4 and 6, and then making it 8 over 2 root 6. Now you could simplify the 8 and the 2 there. If it were me, I would just get rid of the square root of 6. Now you don't have to multiply by the 2. You can just multiply by root 6. Okay? On top, we'll get 8 root 6. On the bottom, those two 6's, those two square roots of 6's, will turn into just a regular 6, and 6 times 2 is 12. Again, now you can simplify the 8 and the 12. Both of them divide by 4, and you get 2 root 6 over 3. You get the exact same answer whether you simplify at the beginning or whether you kind of wait towards the very end. Okay? C is a little bit different in that there's a square root over my numerator and my denominator, but you are allowed to distribute that square root to your numerator and your denominator individually. Okay? And now it's up to you as to whether or not you want to simplify those roots first or not. For this particular one, I am going to simplify the roots first just because I see very obviously what they turn into very quickly. So I might as well simplify right away. And I get 5 root 3 over 2 root 2. Everything's simplified, but again, I can't have that square root of 2 in the denominator. So I multiply by root 2 over root 2. And I get 5 root 6 over 4 because those two, the square roots of 2 turn into a 2, and then 2 times 2 is 4. I can simplify the 5 and the 4, and I can simplify the 6 and the 4, not because they don't simplify, but because one is under a root and one is not. Okay? For letter D, I want you to actually try this one on your own, and then we'll talk about this one to start with in class next time. The hints that I'll give you are that both fractions need to be simplified, but also you're subtracting fractions, so at some point along the way, you are going to need to get a common denominator and combine those. So give that one a try on your own and come to class ready to talk about it the next time we see you.